We are going to get started. Thank you, everybody, for joining us. I am Andrew Zimmer here with JMI TV, and welcome to another episode. We are back. We have only one more episode before we take our holiday break, but since it's so freaking cold outside, we wanted to share with you a new way that we at JMI are keeping your people and your process warm during these cold winter months. So many of you are probably familiar with JMI's 15-plus year relationship with Thermon Heat Trace. Well, today's presentation takes that to a whole new level. JP Hawkins is here with Advanced Mat Systems, a company that primarily uses Thermon Heat Trace to heat things longer and hold temperatures steadier than using traditional insulation. So everything from heated mats that keep pathways clear of ice to heating the steps or the guardrails of a stairwell, heated blankets for process instruments or for valves. They can even heat a ladder, wouldn't that be nice, and safe, especially on the cold, windy days in January. So the more I heard about this product, the more applications that came to mind for not only keeping workers happy and keeping their feet warm, but also keeping them safe in places that otherwise ice and snow would be a safety hazard. So without further ado, here with Advanced Mat Systems is JP Hawkins. JP, take it away.
All right, Andrew, thank you very much. I appreciate the intro. You've covered pretty much all the reasons why we do this.
Thank you.
Again, I want to thank everyone for joining us today and for the invitation to participate with JMI on this. As Andrew alluded, JMI has been using Thermon Heat Trace or working with Thermon for 15 plus years. Advanced Mat Systems now has been working directly with Thermon as our supplier for 10 years now. So we'll be moving into year 11. So it's been a good relationship, and we're happy to keep going with it. Anyhow, as the webinar indicates, and Andrew alluded to, that we heat everything. What we're introducing you today to specifically is the Arctic Pad. It's one of the tools we do just to accomplish that very thing, which is just provide surface heating. As for some of the other products, handrails, blankets, and ladders and whatnot, we can bring those up another day or ask some questions about them in the Q&A at the end. But anyhow, before we dive into the slides, I wanted to talk about what we refer to this as being winterization. Typically in industry, people think of winterization as preparing your RV or your house or preventing pipes and water lines and valves and such from freezing. Or in industrial applications, we can even narrow it down to thinking about using things as heat trace for process temperature maintenance. These are all very important things to address, obviously, especially in industrial settings and applications. But what we're talking about today has more to do with the Arctic Pad and how we address safety. It's an overlooked aspect of winterization in facilities or plants. But winterization and preventing ice and snow in the walking areas or workplace is one of the most important things you can deal with. Slips and falls, without a doubt, are the leading cause of industry. It doesn't matter if it's an industrial setting, a commercial setting, or just a generally public accessible area. If we don't address these things, we already do now with some mitigation, i.e. snow and sanding, salting, snow removal, shovels, all the hard laborious work. What we do here is with the Arctic Pad is we have an active system that just can be used to prevent the accumulation of ice and snow and taking a big approach to it. So if we don't do something in plants and facilities, when there's a lot of workers around, you're just inviting hurt and costs that can go along with it. So we'll get into the slides here, and we'll briefly discuss what the Arctic Pad is, how it works, some of the key aspects of it, and give a couple examples of some applications and projects we've done, and we'll move on from there. Anyhow, what is the Arctic Pad? Most people here, I hope, are familiar with heat trace. Well, the Arctic Pad is by definition, a really heavy duty rubber mat. That what we've done is we've embedded heat trace inside of it. This in turn provides a high traction surface year round. You know, this is a system that can be installed and left in place throughout the summer months as well as the winter. The key component is the slip fall protection, and it has a high traction surface. None of that matters if it's covered in ice. So the purpose of the heating element or the heat trace inside is obviously to provide that snow melting capability. How does it work? Again, for all those that are familiar with heat trace, especially self-regulating heat trace, there's some fallacies and definitions on how this heat trace might work. Essentially, our little graph here describes in the best way I can think of. When it gets cold out, the heat trace generates more heat. When it cools down, it relaxes and it finds its balance. So it's just sitting at a temperature of maintenance almost all the time. One of the nice things about our Arctic pads is they have very, very high thermal mass. Basically, they act like a battery, and we're going to talk about that here in a moment. To make up the Arctic pad, this is just a simple description of the anatomy of it. You know, there's nothing really complicated about the solution, and just really comes down to thinking outside the box as far as how do you get it into place. Very simply, it's the sum of all these components, whether it's the heating element, varying temperatures or watt ranges of heat trace. They all have different aspects or different capabilities. We can create different shapes through our molding process. The polyurethane, or the rubber we'll call it to simplify it, different urethanes, different rubbers for different applications. We have some that are more chemically resistant than others. Those, of course, come with a cost. So, you know, if we consider stairways, which we'll get into later, you may not need a highly chemical resistant urethane, because chances are you're not spilling highly, corrosive chemicals up on stairways. They have a cold lead, which is the power cord to connect them to. We can obviously make them in any shape or dimension and size. And again, one of the last main elements is the high traction surface. For extreme situations, we have some mats that come with steel studs into them, but that's an application that we're just not using too much in industrial, more for the drilling and offshore drilling industry. Our pads for any project can be built to any shape, size, or dimension and configuration. I shouldn't say to any size, but nearly any size. We can get these things from 1 square meter in size, or 3 feet by 3 feet, all the way out to 20-foot mats in length by 3 feet wide. It just becomes a matter of handling after the fact, but we try to do this to optimize the installation. So sometimes you need a really big mat, sometimes you need multiple small pieces.
Hey, JP.
Depends what the project calls for. Yeah, Andrew?
I had a question come in, and they were asking about like mounting or installation. Primarily, when you put these things down on a surface, do they move around very much? You mentioned something about bolting them down. Does that need to happen in most installations, or how do you keep them from moving around?
We'll cover that a bit when we start talking about the project descriptions, but for the most part, to answer it right now, the Arctic pads are typically installed on steel grating. That seems to be a very popular place to get them, and they're built with molded holes, so they are bolted in place. But I should also mention these mats are quite heavy. So they don't necessarily have to be bolted. They can be interconnected, or they can be laid down. They're going to weigh about 5-6 pounds a square foot. So you start talking about them, they're not going to be moving around too much. So if it's a simple entrance, it can be just laid down in place.
Okay.
Of course, when you have elevated areas, you've got to be cautious and paying attention to wind as well. You get some high winds up in Chicago, you might be blowing these things up and around off a set of stairs. So, you're definitely going to want to bolt them down in that case. The anatomy is fairly simple. I did mention something. We'll go through this real quickly. There's a lot to cover about the Arctic pads, and we don't want to make it overly complicated. They are simple, but one of the big features of the Arctic pad over everything else is its thermal mass. There was some independent studying done a number of years ago for the offshore industry, where we wanted to find a system that would conserve fuel and energy for the offshore world, being boats and vessels. And one of the things that was found during this was, in combination with the heat trace, the mats could be cycled on and off, meaning that the rubber or the polyurethane essentially sucked up so much heat, it created a microclimate around the heat trace. So the heat trace would relax, not continuing to draw so much power, and or that zone could be turned off for a prescribed set of time. And you know, these bit of graphs, and this whole presentation will be available later, but these couple graphs or charts here explain that it took almost an hour for the temperature, the surface temperature of the mat to drop to a point of freezing again after it was heated up. So, you know, there are some excellent energy savings. Some people are going to be more concerned about that than others. You know, if these green plans go through all across the world, you know, conserving energy is a factor. It's no different than making sure you have the right amount of insulation on the pipes. Not only to temperature maintenance, but you just don't want to be wasting that energy. So again, you know, there was another chart here, drop it another 10 degrees in Celsius. You know, it took about half the time to lose the speed or the temperature, the surface temperature. So it's, again, just a unique characteristic that the Arctic pad offers that no other system out there does. A lot of any other solutions might be putting this stuff into concrete, embedding heat trace in concrete, as you're familiar with. I believe KSR is the component from Thermon that's used. What's preventing the rapid heat loss coming out of the concrete? You know, you're constantly going to be drawing. So, good characteristic, which in turn goes to the control systems. Now, I know Thermon has the Genesis system and TCM 18s and the old method of looking after them, all very capable of operating the Arctic pads, and they have on projects. What we try to look at when we're designing control systems to work in conjunction with the Arctic pad is capitalizing on that thermal mass, basically designing the system to be energy efficient. You're going to find the south side of a building exposed to the sun is going to need less energy to keep snow or ice free than, say, the north side in the shade. With the smart intelligent control system, the mats can be cycled on and off in the zones that they need to be, as they need to be. So I'm hoping there'll be some other questions about this, and we can elaborate it on a little bit later. Again, control system logic. These are a couple slides giving an example of what we meant by this. In one particular project, what we wanted to do to keep down some of the inrush is we designed into the program that there would be only a 20% energy going into the mats to kind of preheat them. Kept the inrush down on the whole system. In this project in particular, all the mats, it was just about I think it was 45 square meters of mats that were heated for this, but they were all preheated all at the same time. Once the preheating period was finished, they started going into a cycling mode. In this case, half the mats were on at any one given time, and half the mats were off. What we found is that thermal mass of the mats allowed us to keep the surface temperature at 2 to 3 degrees through this cycling, as if you had the mats on 100% of the time. So, you know, there was really no difference other than we were saving energy. You know, we're only using 50% of the power in this case to do this.
So hang on. So this is cheaper to install, from what I've, in my experience, cheaper to install than putting heat trace in concrete. It's cheaper long term because it has a better it holds the heat longer, and it's more consistently holding the heat than concrete. And with this 50-50 cycling, you're going to be a lot more energy efficient using this system as opposed to a concrete system. Am I correct in all three of those things?
You're for the most part, the cost on the concrete is the one area that's questionable. Of course,
Okay.
it depends on how much union labor is going into the work, and where the project's being installed. The mats, we're not going to say they're inexpensive, but when you combine the labor that can go into installing in the concrete, yeah, it can be a wash across that. They are definitely more energy efficient, which is a cost reduction. So you're right on the other 2 points, Andrew.
Okay, cool. Yeah, and that was what I had experienced was they had a lot of union labor guys, and these are, I mean, for this application that I was talking about, it was just 2 straight lines it was to heat a tank farm. So the installation was really simple. It was essentially laying down mats. So anyways, so go ahead. Sorry, didn't mean to interrupt you, but go ahead and keep going, and then we're going to get to the Q&A pretty soon here.
That's no problem. You brought up a good point. The tank farms that we were talking about, the concrete was already poured. So that's a big factor in where these mats are applied is we are an afterthought. Winterization of walkways and stairs is typically an afterthought. So, to install or to rip out concrete or to try and do something after the fact is very costly unless they can just apply the mats to it and it's not such a big deal. Then you're just looking at the electrical infrastructure components for the install. Just expanding on that, this was an example of taking it down to 25%. So again, just reducing and conserving energy as much as possible. For us, we have to focus a lot on the offshore industry because they have specific and hard and set rules out there for winterization. Fuel out there is what costs money. Land-based facilities, they have a lot more discretionary energy available. So not quite as important, but it is possible to accomplish, especially if you start looking at commercial applications. Less industrial and commercial becomes a thing because a building, a rooftop to inspect an HVAC system up on top of a mall complex, for example, they may not have an enormous amount of energy available to put onto more consumers such as the Arctic pad. So typical applications, we're going to kind of run through this fairly quick. I think you can all imagine what we're looking at is refineries and facilities, manufacturing plants, loading terminals up there, from the port facilities around the Great Lake region. You guys are highly susceptible to icing. You've got lake effect snow that's crazy. How are they addressing the snow melt or the safety factors at these facilities now? A lot of elevated walkways, obviously, commercial buildings, rooftops, and stairways. Stairways are probably the biggest area we're addressing nowadays. And this is typically based on a risk assessment done by safety people within a plant, a refinery, or a facility. Moving from one elevation to another is risky as it is with people. You put ice and snow into it and it increases it. So stairways are big, very, very simple to install and very simple to address when we use the Arctic pad. A couple examples we want to give. So there's some sort of real life situations people can reference up there is we're currently in, completed phase 1 for Marathon in Detroit, their plant there. They had an MBR unit, which is a bacterial tank system that they were doing to basically recycle and clean up the water to reintroduce it back into the rivers. When they were bringing all the warm water in coming through the process of the plant, there was so much steam and vapor rising from the water and the tanks that it was actually creating ice everywhere around the grading on the walkways. And the guys had to continually monitor what was going on in the tank. So it became a real risk hazard for them. So 2 years ago now, we installed the first portion of the package at Marathon. Extremely successful. So much so that we're going to dial back the amount of, not the amount of heat trace, but the wattage of heat trace we're going to use in that. If you can just see the slide, now or later, just an example, the picture there is showing that the average temperature of the Arctic pad in the image is sitting around 97 degrees Fahrenheit, and it was just below freezing out there. So we had way more heat than was needed. So we're dialing that back a bit, save them a little bit of energy, and we'll go from there. But extremely effective.
JP.
Yep.
We are a little bit short on time, but I wanted to make a lot of time for questions.
Yeah,
I know we have in the presentation a couple more examples, and I know we've got a handful of people here that probably have some questions or maybe some applications where they might ask. So I'm going to unmute everybody as we go through these next few examples. I think everybody's on. Can everybody hear me? Can you guys all talk now?
Doesn't sound like we have much of a crowd, Andrew.
I guess they're all working on letting their mics go. Lorenzo, can you hear me? Oh boy.
Yeah.
Alrighty then. Well, I figured this would be a little easier to be a little more open for them as we go through the examples. JP, I'm excited to hear about this one. This was the the university one is next. Go ahead.
Yeah. So we'll just really quickly cover them. So the previous slide, we're talking about a refinery application, industrial, class 1, div 2 area in this case. So obviously, in all the same approvals that typical heat trace does. This facility in York in Pennsylvania was just a manufacturing facility. They had some ice and snow problems at their entrance for their employees. They said they had about 1,000 people go in and out of these doors every day, and they were getting someone slipping and falling on them about once a week. So just real quick fix, just heat the stairs and prevent that accident from happening. I'm not sure if you're familiar, but that's a simple control that's in one of the images as well from ETI. It's a simplified way of running the controls as opposed to looking at a bigger system from Thermon. Commercial application, another one. Fairfield, Connecticut. The university was building a new facility for the students, and they wanted to have the fire escapes on the structure or the buildings had to be heated. So again, this was a nice application because we were able to plan it pre-construction. So in this instance, the mats and all the electrical work was fully integrated with the manufacturers of those stairs. So it worked out quite well. It's been operating. Sorry, I'm showing 2020 there right now. That's incorrect. It was actually installed in 2017. So they've been running for 3 years now with no problems.
Mattress, so
To Chicago.
IKEA.
I think I can hear other people there unless we're listening to an IKEA commercial, Andrew.
Uh-oh.
You still got me, Andrew?
Yeah, I think someone's wife came in on the Q&A.
Yeah, that's no problem. We're heading off to IKEA. We're good.
That's fine.
Well, we can put a heated mat underneath a mattress, but one of the last ones I wanted to quickly bring up was, and it's the most recent, was a train platform for the MTA or Long Island Railway in New York. What they're looking at doing right now, and this was a trial that was installed this summer, is heating all the train station stairways and platforms. 2 reasons. 1, public safety, slips and falls. 2, Their snow removal costs and expenses are astronomical. The amount of salt they go through in a year is crazy. The amount of union labor they have to deal with is astronomical. So again, this will be the first year for this, but we're projecting that it'll be quite extensive. And again, this is just one train station in New York. We see a lot of opportunity with the other stations throughout Chicago, the Midwest, the Northeast. We can see some applications, but this product was made to be a little less industrial looking. So it's got a softer finish. The surface texture is done with a different material, so it's not quite as gritty because we have to anticipate people walking with nicer shoes and footwear per se. And year round. So you're eventually going to have someone out there with flip flops. So we don't want something too industrial. One of the last items that we've introduced now is we're doing architectural panels. These are self-supporting load-bearing structures. So if we can preemptively plan with the facility, we actually will integrate steel grating into the pads. So it would be a one-off bolt in place as opposed to an add-on after the fact. Or you'll find a lot of elevated rooftops, which is what we've done now, is these will be elevated heated panels. So they can have the HVAC inspection pathways, or an entire roof can be heated. They're already kind of doing it nowadays using some invent system, but they still have to put down 2-inch thick concrete blocks over top of the other heating element. With this finish and the way we're addressing this, we're putting the heating right at the surface, so it doesn't get any more efficient, and we can make it look like anything. So there's a lot of options that go along with it, a lot of colors that go along. So that's a new line that's coming out, and maybe we'll do a follow-up on the commercial stuff in the course of the winter, or getting prepared for summer. Yeah. I think that kind of covers the gist of it, Andrew. If we have any immediate questions.
Well, thank you very much for the presentation. It's open to questions if anybody else can bring in, but it looks like there's a wide variety of applications for this. And correct me if I'm wrong, it appears that you can make them out of almost anything, and almost any area classification or any style for the more commercial stuff can be achieved. Is that right? You can make these out of a lot of different materials, right?
That's correct. Again, I kind of alluded to in the beginning, we're limited by, if we want to keep our mind in the box, every application is going to need something different. It could be a different material we deliver it in. I think, we were dealing with the tank farms and we had some very corrosive chemicals we had to address. So we ended up taking the Arctic pad in that case and encapsulating it in steel, which was going to provide that corrosive resistance. But the options are really endless for us. We've yet to come up with something that we can't deal with.
Cool. And there was one other thing that I did want to mention. If for those of you out there that might have an existing steam trace system, you can tap right into a steam trace system too, right? With these?
Yes, we've done some work on that where we can actually build them so they'll accept tubing. I don't want to say tubing bundles, but we are able to build the Arctic pad as a non-electric, so you'd be able to run and plumb steam through them.
Cool. All right. And
someone's got a question about the life expectancy.
Yeah.
Right now, we're shooting outwards of 15 to 20 years. The polyurethane is a UV stable urethane, and it's also completed in a top coat that is UV stable. From time, we're also looking at 1 inch thick. So to break down 1 inches or 1 inch of material to make it to a point of brittle, we haven't seen it. Originally, these mats were designed as non-heated mats for the drilling industry and the offshore world, and they've been out there for just about 40 years now, this polymer, and we don't get mats come back to us that have failed because of sunlight by any means.
Hey, oh, I got one more question. While this question is being answered, I just realized that I have one of these mats in my house. I thought it was in this room, but it's in my garage. So, JP, do you see that question about Class 1 Div 1?
Yes, the Arctic
I will be
pads
right
can be
back.
used for the Arctic pads can be used in zone 1 areas. Same with heat trace. It comes down to the electrical infrastructure supporting the Arctic pad. You know, we're talking about different junction boxes, different housing units, and things like that. Because the heat trace is completely encapsulated, there's no issue with that at all. And you know, if we need to, the heat trace can be shielded in conduit and run straight into the appropriate housing. I hope that answers the question. Perfect. And I guess Andrew kind of left me hanging, holding the bag here. You know, I kind of sped through some of these things fairly quickly. Obviously, we're going to make this presentation available for anyone who wants to get it. You can visit us, you know, either through our website or get in touch with us through Andrew or anyone at JMI. We can answer future questions. Project designs, concepts, it takes us not much to put together a simplified proposal if people want to evaluate and just have a quick look at things, see how it might fit into their applications.
Did you miss me?
Just for a short time.
So here is the actual Arctic pad. You can't feel how heavy it is, but just this little piece, which is about the size of my upper body, it's pretty durable. And is this the polyurethane, JP?
That one is made out of a polyurethane, yep.
Okay. And yep, it can be as simple as that. Not that wouldn't meet too many area classifications, but you can simply plug it in. And here's a different material you can make it out of as well. So I'll be passing this around the table so everybody can see it. All right, so Class 1 Div 1, cool, we can do that. And I think we just, if the pads are to be bolted down, are the locations that are safe to drill? Did you answer that one too?
Oh, I didn't see that question. My apologies. We pre-mold the holes for mounting the Arctic pads into them. So we'll do that a couple different ways. It'll be a countersunk hole so that when the fastening hardware is in place, it doesn't actually protrude above. It'll become a flush fastening, you know, hardware, nut and washers.
Yeah, right. Okay, perfect. So there would be no way that the heat trace, as long as you're following those holes, the heat trace wouldn't be damaged. You wouldn't have that problem, right?
Correct. Now, from time to time, people have had to drill their own holes in. That's kind of a do at your own risk. But the heat trace is, you know, we know exactly where it is based on drawings. And if you got a thermal camera, if you need to drill a hole and you have a thermal camera, you can identify where the heat trace is. Our typical spacing is 2 to 3 inches between rows. So, you know, there's quite a bit of room between the rows of heat trace.
I'm gonna write that down for this person. Yeah, I would imagine with a thermal camera, you would see little variations where you'd have like, is this? There would you would kind of see this in the thermal camera. Yeah, you've got a picture of it, I think, right?
Yeah, if you're looking at the slide now, you can see the lines of the heat trace. You know, this is very early when the mat's heated up. We have a high conductivity on the upper surface of the mat. We didn't really touch on that in any of these images. but the top surface of the mats, you know, eventually you won't see those lines or the striping as we all know it to be. That'll become blended.
Okay.
All right.
Well, we
Well,
are
again, Andrew,
at our time limit. Thank you very much, JP, for doing this, and we appreciate your time. If you can you go back to the last slide real quick? So if anybody needs anything, I think he's going to pull it up. This is our contact information, and thank you very much for coming. So we'll talk to you soon.
appreciate it. Everyone